Now, you may have encountered a couple examples in your homework so far that show that the limit can fail to exist when it approaches a different value from the left side of C and also when it approaches from the right side of C. You're going to get different outputs sometimes. So this type of behavior can be described more concisely with the concept of a one-sided limit. So a one-sided limit, we're going to use this notation. You'll see it says as the limit as x approaches C, and we've got this little negative sign up here. That's going to become significant. Of f of x is L sub 1, so the first limit. In other words, f of x approaches L sub 1 as x approaches C from the negative side. In other words, that's just approaching it from the left. Now, if we switch that minus to a plus, that just means we're coming from the right. The way I think about it is we're approaching it from the negative side, so we're coming from the left, and then for the right, we're approaching it from the positive side, in other words, from the right. For example 3, we're asked to find the limit as x approaches 0 from the left and the right sides. So, sorry, let's draw this out, two separate cases. So we're going to have the limit as x approaches 0, and we're going to put a little negative up there. It looks like it's a negative as an exponent, and that's how we're going to write it, of 2x over x. Now for the right side, it's going to be the limit as x approaches 0 from the positive side, coming from the right, of that same equation, 2x, the absolute value of 2x over x. Now from here, we're going to put this on a graphing calculator. Let me see if I can switch this without having to stop the video. All right, that worked. So let me type this in. Now on your graphing calculator, you do have an absolute value button. Let me stop that. There we go. The absolute value button you can find by pressing math. And then you can see the second column says number, or num for number. So we'll go over that, and it says ABS. Now, if you're using a TI-84 or an 84CE like I have on the screen here, when you choose that, it'll actually open up the absolute value bars. If you're using a TI-83, it'll say ABS. Just make sure you're closing out that parentheses. So we're going to have 2 times x, so 2x, and then get out of the parentheses, and we're going to divide it by x. Looking at the graph, looks a little something like this. You can kind of see where the values are. So like over here on the right side, it's up at x equals 2. On the left side, it's down at y, or at y equals negative 2. If you go to the table, it's going to verify the same thing. So we're going to say coming at it from the left side, coming from the negative side, it's going to be approaching negative 2. But from the right side, it's going to be approaching positive 2. So let me see if I can switch back to this a second. There we go. So we're going to say the limit as x approaches infinity from the negative side is negative 2, and the limit as x approaches infinity from the, sorry, I just keep saying infinity, as x approaches 0 from the negative side of the absolute value of 2x over x equals negative 2, and the limit as x approaches 0 from the positive side, from the right side of absolute value of 2x over x equals positive 2. So what we're encountering here is two different outputs. So this function approaches different limits from the left and from the right side. So in this case, we're going to say the limit of f of x as x approaches c does not exist. In order for it to exist, it has to be the same value from each side. So for the existence of a limit, formalizing that definition, if f is a function and c and l are real numbers, then the limit as x approaches c of f of x equals l, if and only if both the left side and right side or limits exist and are equal to l. They have to be the same limit.